Hello, everyone. This is Dr. Yuzo. This is ECE 341 Power System class. Can you guys hear me? All right, thank you. Thank you. We can move on here. So this is the shared outcome notes here. This part of knowledge is regarding the optimal dispatch. You're trying to find out the minimum cost to generate certain amount of requested power. Okay, this is the idea of the problem you need to keep in your mind. And here we have, first of all, the individual generator cost function. Okay, it's modeled. It's a modeled. Okay, in such way is a function of power quadratic equation with different coefficients, constants. Okay, so this is individual one, individual generator I cost function. Okay, and of course this is not our ultimate cost function, objective function, not yet. Okay. And this is our objective function. Okay. In other words, we are trying to minimize this guy. We're trying to minimize this guy, which is equal to the summation of all of the generator cost, right? That makes perfect sense. And the I is indexed of individual generator. And N sub G here on the top is the number of generators. Okay, it's the number of generators. Sum all of the individual generator cost function together, then you end up with the total cost, which is our objective function. This is what we learned last lecture. And who is the constraints then? Here is the constraint. Constraint function, which is the demanded power from the customer. Obviously, this is not negotiable. I mean, the customer is asking for this amount of power, and then you provide this amount. Okay. So summation of all of the generator power is equals to the demanded power. Okay. This is the constraint function. And combining these together, and then we establish our Lagrange multiplier, which is equals to the objective function plus a introduced unknown constant lambda times the constraint function. And also you can tell both objective and constraint function are a function of what? Remember back in the mathematical problem we do with the objective function and constraint function. They both are a function of the same independent variables, right? So here, who is that independent variable? Who is it, or say, who are they? Anyone else? Who is the independent variable? We're trying to match what we have done in the math problem. Power, very good. The PI. Yeah, PI is the independent variable. Independent variable. PI is the independent variable. Correct. Okay. Correct. So this is very important, okay, because we later on, actually right after, we're gonna start to look for what? Derivative, right? So if you're not clear on who is derivative, of course, you won't be able to do the correct derivation here. Okay. So let's go ahead. So to find the minimum value of the objective function, you're gonna do what? Partial derivative of the Lagrange multiplier with respect to what? Independent variable. You just mentioned is pi, right? Equals to 0. And partial derivative of L with respect to introduced and known lambda, right? That's it. And that's it. Because here we only have one constraint function, which is the demanded power. We are not involving others like the limitation of the generator. We're not involving the constraints like the loss, right? The power loss. We're not involving those. We just talk about the cost function with this requested or say demanded power as the only one constraint. Is obviously a equality constraint, right? It's an equality constraint. That's why we only do the partial derivative for two things: independent variable pi and introduced unknown lambda. From here, with respect to the pi, this guy equals to what? This function derivative of pi equals to the partial derivative of c sub t with respect to pi, right? Plus, how about the second part? How about lambda times PD is what? Independent to pi. Does it make sense? How much power customer demand has nothing to do with how much power each generator gonna generate. It's not up to the generator. A generator is following the demand power. So PD is independent of pi. Therefore, this is 0. And minus the summation, the partial derivative of the summation with respect to pi. So this equals to what? Anyone can tell this? This guy with partial derivative with respect to pi equals to what? Can anyone tell? Any thought?
Can't we basically expand that summation just because there's one term there and say that it's pi times n sub g?
Pi times n sub g? No, there's no times, right? This guy, if, as you said, if we expand it, equals to what? P1 plus P2 plus Pi plus up to Pn sub g, right? This is the extension. So from here, looking for the partial derivative with respect to pi equals to what? No. Not seeing the correct answer yet. Do not overthink. Okay. What is it? Pi? No, close, but partial derivative. Partial derivative. Number 1. Does it make sense? It's P1, P2, all the way to Pn, G. That's only one term, which is pi, has something to do with pi. The rest of the term here and before and after pi, all of those p's are independent of pi. That doesn't make sense. It's a little bit, yeah, it is a little bit abstract, but think about it. Does it make sense? The P's before and after pi has nothing to do with pi. They're independent of pi. Only pi itself is depending on the pi. So the derivative of pi with respect to pi is 1, right? Does it make sense now? And this equals to 0. All right, if so, then we can move on to the second equation here. Okay, second equation, we're looking for partial derivative with respect to lambda. Then this guy has nothing to do with lambda, right? This is 0. The second one is the entire parenthesis is the coefficient of the lambda. Then 0. Now this is the resulted 2 equation. If you further derive them. And here, is just partial derivative of the objective function c sub t with respect to pi equals to lambda. Second is just our constraint function itself, right? And if we name them as equation 1 and 2, we can further do more derivation. So from the equation 1, what we can say is we want to expanding the c sub t, because c sub t, remember, is what? Contains one summation as well, right? So what you're going to do is c sub t equals to what? C1 plus C2 plus Ci, and then plus up to C sub ng, right? Exactly what we did here. And then therefore, if you're looking for the partial derivative of this guy with respect to pi, it equals to what? Same question, basically, right? So this time, can anyone answer? Same question as this one. Right? What is the answer then? What is it? Anyone? No one? Here, Kevin says it's beta plus 2 gamma. It's a pi. Actually, he is right. However, he's jumping the step, actually. So what this result is, how about this guy? Does this make sense? Any questions? Same reason as up here, okay? Same reason as up here. The C before and after Ci here has nothing to do with pi. Does it make sense? Only Ci is depending on pi. So partial derivative of the summation here with respect to pi is nothing but equal to the derivative. Okay, it's not partial anymore. Why is not partial anymore? Because Ci has only one independent variable, which is pi itself. Has no other independent variable, right? So it's a derivative. And therefore, derivative of Ci equals what? Ci is here. Ci is here. So we are looking for the derivative of this guy with respect to pi. We end up with the results as Kevin did. 2 gamma I pi equals to what? Ah, lambda, I mean. Lambda. This is the equation 1. After a little bit more derivation. So we can tell from here, what we can do is, again, once again, go back to the mathematical problem. We are looking for what? Before we obtaining the minimum value of the objective function, we found what first? Independent variable value for that minimum value happen, right? So who is the independent variable? Pi, remember here. Pi equals to what? Do one simple algebra, you end up with this. Okay. The generator I power Pi, of course, to make what? Minimum of our objective function C sub t happen. Okay. Your generator I generate how much power to make minimum value of the objective function happen? This amount. Of course, I gonna vary from 1 all the way up to n sub g, right? So the other side of the equal, we have I varying from 1 through n sub g as well, right? Coefficient beta I and gamma I. Does everything make sense so far? Okay. And this is called what? This is called coordination equation. Equations, plural. It's plural. Why is plural? Because this is I, representing up to n sub g number of the generator. Coordination equation is guaranteeing your minimum of total cost to happen. So if this is fine, then let's think next step. Okay, mathematically, what do we want to do next? Can you link what we have done in the math problem to this power generation problem? What we should do next? Anyone can link the math to here? What we should do next? Because establishing the L function, okay, right? And after that, be looking for the partial derivative equations. From the equations, we find independent variable value. Okay, good. What else we need to do? Kevin mentioned the equation 2 for what? For a question mark. Yep, we need to take care of the question equation 2, but for what? What's the idea, or say what's the logic? Because so far as everything is following the logic from back in the math problem, right? L function, partial derivative. From partial derivative, we're looking for the independent variable value. And what's the next? Anyone has any memory on what happened back in the math? We're trying to learn the logic, okay, or say the reasoning, how to think, or in this way we can really keep something out of the math, because the math, how the math related to the power generation problem. Okay, this was one of the questions from, I think, Anil. He asked how these two related. Here is how they related. Yeah, we are applying the math idea, the logic, on this real problem. Okay? So after having independent variable value found, what's the next? Ryan said is plug back into the objective function to find the what? The minimum value of the objective function. Great. Okay, this is what we want to do. Exactly right. However, what else problem we find? Look at this result. We know beta, we know gamma. These two are given because they are part of the modeling. Right? They're part of the modeling, so they are given constant, no problem. However, what? We don't know the lambda value. We don't know the lambda value. So here we must find the lambda value as well. Then no wonder we are doing two equations. You see, two unknowns and the two equations. The perfect sense, because theoretically we should find both of them. Right? This makes perfect sense. Just that in the math, back in the math problem, we didn't have to find a second unknown. Enough for us to find the minimum value of the objective function. However, here you have to find both, right? You have to find both so that you are able to find the minimum value of the objective function here. This is the difference. This is the difference. So after value of independent variable here, you still need to find the other unknown here, lambda. Does it make sense? So this is why we need equation 2. Okay? This is why we need equation 2. Let's see how to use the equation 2 to find the second unknown, lambda. Does this logic and reasoning make sense? We are doing nothing but following the exactly same procedure from the math problem. Okay? You should have such feeling. You should have such feeling. Okay, so which essentially is talking about how to apply a mathematical algorithm onto the real application. Okay, this is actually the nature of the problem. How to apply that? How to find lambda? We need a second equation. Okay, it's here. So PD equals to P1 plus P2 plus Pi plus all the way to En sub G, right? This makes perfect sense. We just extending this guy equation, summation, extending the summation. We end up here, right? And if we substitute p's by the coordination equations, what do we end up with? How about this? P1 is equals to what? Lambda minus what? Beta 1 divided by 2 times gamma 1. Does it make sense? This is P1. P2 is what? Lambda minus beta 2 divided by 2 times lambda 2, right? Gamma 2. Plus all the way, of course, including the Pi itself. Plus all the way to . NG, our generator NG. Right? Yeah. Does this make sense so far? And then further it equals to what? How about, because we are trying to find a lambda, right? And keep this goal in mind. So how to find lambda? We want to pull off lambda as one common factor, right? How to do that? How about you pull up lambda over 2 times gamma 1 plus lambda over 2 gamma 2 plus lambda divided by 2 times gamma I plus lambda divided by 2 gamma n sub g. Right? This is pretty much one term. What I did here is just what? Splits each fraction into 2 fractions, right? Then what? How about minus what's left? Beta 1 divided by 2 gamma 1 plus beta 2 divided by 2 gamma 2 plus all the way beta n sub g to gamma n sub g. Right? And this equation is the PD, okay, equals PD. Does it make sense so far? Any questions? All right, if this is fine, then keep moving them. Once again, keep in mind, we are looking for what? Lambda. And to make it easy, what do we want to do? What you want to do is write these back to summation, right? Back to summation. How we can do that? Lambda, mutual common factor, times summation I from 1 to n sub g, and this is what? 2 gamma I minus summation I from 1 to n sub g, and then beta I divided by 2 gamma I. Does it make sense? All right, if this is fine, then well, it's time to find out lambda. Because if you look at this equation, this of course here is PD. Okay, we just derive following this step here. So this is PD. So PD we know, right? This is something given. How much power the customer want has to be specified. And then gamma I, beta I are also part of the modeling, so we know them as well, right? Constant. So now it's one equation, only one unknown left, lambda. So we can derive lambda value, which is equals to PD plus summation of this, right? So from here, two red boxes containing two solutions for two variables. And one independent variable pi, the other is lambda. Right? Obviously, you want to do this first, right? But does it make sense? This one goes first. Why is that? In the problem solving, why you want to find lambda first? Why?
Because lambda is in the other equation, so we can just plug in that answer.
Exactly right. Okay, exactly right. Because obviously you can't do this first. Like we said, we don't know the lambda value yet, right? But the second equation here, you see what? Everything is given, right? Betas, lambdas, PDs, they're all given, right? So you immediately come up with the lambda value. Substitute lambda here by this red box, you are ending up with the optimal individual generator PI. So once again, if you recall the math, we have two partial derivative equations and we have two unknowns, independent variable pi and introduced known lambda. Okay? We got them both. We got them. Therefore, what's the very last step? What's the very last step? Now is the time for what? For what Ryan mentioned. Ryan mentioned plug that into the objective function, because never forget, we are looking for the minimum cost. So pi and lambda are not cost yet. Our minimum, or say optimal cost, is here. This is the definition. And then what you need to do is just what? Sum up all of the individual generator cost function. And each one here, of course, equals to, say, oh no, I'm sorry. Not I anymore, right? They need to be specified. Does it make sense? So this is the final answer. What's the minimum cost? Here we go. Take a look. Let's see if it makes sense. Any questions? So what we need, two red boxes. Yeah, basically two red boxes. And at last, don't forget to find the minimum cost. Okay, that's it. And if this is fine, then all right, let's try examples to see how to really apply them. Example 1. 3 generators. Cost functions are given. C1 equals to 900 plus 3 P1 plus 0.004 P1 squared. C2 equals to 400 5.5 P2 plus 0.006 P2 squared. 200 8 P3 plus 0.09 P3 squared. As a 3 generator cost function modeled like this, given. Okay, they're given. So here is telling you the total power is 800 megawatt. And here, PI in megawatts as well. So neglecting power loss and generator limits, find question 1 is called optimal dispatch. 2, minimum total cost. So what does it mean by optimal dispatch? What does this mean? Well, this is our title of the module. However, what does it mean? This is pretty much asking literally what does it mean, English. Translate that to our problem here. What we're looking for as the answer for optimal dispatch. What is it? Of course, that's the description. A PI. Here we go. Very good. Okay. Sawyer's answer is right. This optimal dispatch is asking for what mathematically? It's looking for PI. Okay, you have 3 generators. Okay, you need to specify P1, P2, P3 respectively equals to what? That is the answer for optimal dispatch. You are assigning the total 800 megawatts to 3 different generators. So each one of them is getting how much assignment? That's the optimal dispatch. Does it make sense? Right. So you know what to answer. Okay, you need to know what to answer. And the minimum total cost, this is easy. This is just a C sub T. Right. And if this is clear, then go ahead to do this yourself. Actually, I'm not expecting any trouble from you guys, but you just try to present the formula. This is the Lambda formula you need. And this is the PI formula. Well, this is the best I can do for you.
how is it that we plug in for a P of D?
How we plug in the P of D? Well,
Yeah.
you need what? Well, after identifying who is PD, then just plug in. What do you mean? Like how to plug in?
I mean, like, do you want us? Because if we take P of D and that equals a summation of P of I, right? Do you want us to plug that in or no?
PD equals summation of P of I. That's right. But here, PD is given. Come on.
Oh.
The total required power is 800. That's the P. That is right. P1 plus P2 plus D P3. Yes, is right. However, you're not doing anything like that. You don't have to. Does that make sense? PD is given. Required total power is 800 from customer. Then PD is 800. True, it truly equals to summation of P's, PI's. Yes, true. But all right, 5 or 6 minutes. Go ahead. Or maybe 8. This is the first example. Make some mistakes, okay? You want to make mistakes now, rather than during the exam.
And you said that was 800 megawatts?
Yes.
Okay.
It is down here. It's down here, Kim. If any other questions, just immediately bring it up. The best time for you to study, for you to learn something. This is your best time. Anyone reach any money? Reach any money value as the answer? I hope I can reach some money, but I only have answers here. None on the paper. First of all, what is the lambda value? Anyone got any lambda value? Since obviously this is the first step, right? So first step, lambda equals to what?
I got 8.5.
Good. Okay, that's the good. Good. 2 got that number too. Good. 8.5 is the correct lambda value. And from there you can find what PIs, right? PIs. We have 3 P's to be found. Okay, remember that. And in this problem, another thing you need to be very careful is listen up. Is the unit. Okay, the unit is a little bit tricky. The unit is a little bit tricky. All right, give you guys a couple of more minutes. Let me see the solution here.
Are the cost functions in terms of megawatts? I gotcha.
Canon got 1200 is what is the no Kevin, the Sawyer 1200 as the minimum cost. Is that minimum cost or what? What is this 1200? Good. 2 got the correct answer. Okay, 2 correct answer is way more than 1200. Okay, the cost is way more than that. Okay, let's do this problem together then. Do this problem together. So this is the problem, and like I said, first we want to find the lambda value. Lambda value in details is following the formula. So PD 800 plus 2 times 0.004. Numerator is 5.3 plus 2 times 0.006. 5.5 is numerator. 2 times 0.09. 5.8. Denominator is 2 times 0.004, 2 times 0.006 plus 2 times 0.009. Okay, this is the lambda, and equals to 8.5. Very good, very good, very good. Noah get the correct answer too, and also very good. Noah noticed the unit easy. Very good, very good. Anyways, we go back to first one. The lambda. Lambda is equals to 8.5. What's the unit? Lambda has unit too, right? So what is unit? Anyone has any idea or any thought? Anyone? Megawatt cube? No, no, not a megawatt cube. Any other thoughts? What? No. It's a little bit tricky. We need to answer this question by looking back to our notes, equation 1 here. Now, tell me, what is the unit for lambda? Any thought? From equation 1 here, what is the unit? Keep thinking, okay? All of these thinking are exercise of your brain. They're very useful. Trust me. Dollar per watt? No, but close.
It's not like dollar per megawatt, right?
Here we go. Neil is right. It's dollar per kilowatt. Well, the given is mega. Okay, so we are not talking about a kilo then. Dollar per megawatt hour. Okay, very good. Dollar per megawatt times hour. Okay, this is the unit for our lambda. Why is that? What is unit for C sub t? Noah just mentioned is dollar per hour, right? The derivative was to the power and divided by power, basically. You divide by power. Dollar per hour divided by power equals to dollar per hour times hour. Does it make sense? This is how we got it. Yeah, this is how we got it. Remember this, okay? Remember this unit. It matters. It matters. And after having the lambda, we go to P1 through P3, of course. P1 through P3. And then we just need to plug in the P1 equals to minus beta 1, 2 gamma 1, then just equals to 8.5 minus 5.3 divided by 2 times 0.004 equals to 400 megawatts. And then following the same idea, we find P2 and P3, 250 and 150 megawatt. Of course, after finding all of the PIs, need to do a check, right? Remember what John just mentioned? John mentioned the total PD is equals to what? Summation of PI, right? So 400 plus 250 plus 150, is it equals to the required 80? Not 80, 800. Is it? 800. Because otherwise it's definitely wrong. Does it make sense? You can check. You don't have to wait until the solution is presented to know whether is your answer is right or wrong. Okay, if you end up with exactly the total summation is 800, I think you're right. It's not quite likely to be wrong then. Right, if this makes sense, then at last the CT minimum just equals to C1 plus C2 plus C3. Now is what just a matter of plugging the number, right? 500 times plus 5.3 times 400. Plus and the plus, right? You substitute PIs into the individual generator cost function, and total cost is 6682.5. Unit is, once again, let me use the red color, dollar per mega, no, dollar per hour, okay, megawatt hour. There's no megawatt, dollar per hour. So each hour, your cost of generation is as high as over $6,000. So how much we gonna pay per hour? Of course, it's up to how much power we really use, right? And also the per hour money unit price definitely is higher than this. We're not going to pay the generation cost, no. We wish so, right? But that's not possible. Any questions? There's some details you need to be careful. For example, the units. For example, how to correctly identify the betas and the gammas, right? The formulas are in terms of betas and gammas. You need to correctly identify them out of the given individual generator cost function model. It's very, very important. So in the exam, calm down. You find the beta is the coefficient of what? Pi. Gamma is the coefficient of pi squared. Therefore, of course, lambda is the constant term, right? Be very careful on these. Okay. Any questions? All right, if no questions, let's talk about the review. Okay, review. The midterm 2 is in a week, and hopefully all of us can get a decent grade this time. First, the exam time remains same as the midterm 1. Okay, I'm gonna apply the exactly same time slot as the midterm 1, 90 minutes and plus 15 minutes for uploading the file. Okay, and then we're gonna have 4 problems. We're gonna have 4 problems. We're gonna have 4 problems. So problem 1 gonna be a math problem, mathematical problem. What is it? Iterative method. Find root of a nonlinear equation. I understand maybe your calculator is able to find the roots directly, but please present detailed steps, okay? Detailed iteration steps. You need to present those weight a lot of points. Oh, I just saw the question from some of you regarding the time. I can't remember it. Yeah, starting at to most of you guys at least, starting at 3:35, ended by 5:05, and then plus 15 minutes, I think, up to 5:20 eventually. Okay. The timeline. And continue our review here. So given the equation, okay, so in this problem, I'm gonna give you a nonlinear equation and specify a particular iterative method, because we learned two, right? One is Gauss, the other is Newton, right? I'm gonna pick one of these two, okay? Either this or this. You need to be careful to follow that particular method. It's very important. For example, if I'm asking the Newton, you give me the Gauss, step by step, everything perfectly right. Well, however, you're using the wrong method. Well, you lose quite a bit. You're gonna lose quite a bit point, okay, because you're not presenting the things I'm looking for. Okay, be very careful which method I'm asking for. It could be either one. It could be either one. This is problem one. And then problem two is the power flow. The power flow system. Given the per phase network, and also the bus voltage, find missing line flows, line loss, and bus power. Be very careful. I'm asking you to find the missing ones. Okay, missing ones. Either today or maybe next lecture on Wednesday, I will review the quiz from where you can tell what is meant by missing ones. Because some of the power already given. Some of the power already given. Some already given. Okay, some of them are already given. You're not spending your precious time on finding those. That's absolutely wasting time. Some of them already given and labeled. Given and labeled. From reading the graph, you can tell what is given and what is the power. So, by reviewing the quiz problem is a very good example for you to exercise. Okay. This is the problem two. Problem three. Once again, this problem. That's problem, and find the minimum value of objective function with constraint, maybe equality and inequality. I'm planning to give you more than one constraint function. This math problem. Problem 4 is just a optimal dispatch. Optimal dispatch problem. Okay, we have example for this module. So overall, midterm 2 is easier than midterm 1, but same weight, right? Same weight towards your final grade. So midterm 2 is your best chance to improve your GPA in this course. So you don't want to miss. You don't want to miss midterm 2. Any questions? Any concerns about the midterm 2? Is every subject clear to you?
Are we gonna have to draw the power flow diagram for number 2?
Yes.
Okay.
Yes, you do need to do that. So basically, it's a find and label, let's say. Oh, the draw. Oh, oh, I see what you're saying. Now I see what's Connor's question. His question is actually asking because the given power diagram, the per phase network, is given on the computer screen, right? you need to repeat or say join that network on your own paper. Yes, you have to. You have to. Yes. And this gonna cost you a little bit of time. Hopefully it won't be too long because the network, it won't be very complicated. 5 or 6 buses. No, I'm not planning to give you that.
Could we have like a pre-printed out one?
Pre-printed out one. You're saying, do you have the?
But like, you know, all the buses and the lines already pre-printed, like the handouts. But
How can I do that without presenting the real problem?
Can't you just give us like one without values and then you give the values in the test?
Without values.
I mean, we don't have to, but you know.
Because the reason I'm not thinking of this yet is I think the given network is not going to cost you too much time to repeat. So I think it's fair to ask you to repeat join it, because never forget, usually the students only have 80 minutes to conduct the exam. You guys have what, 90 plus 15. Of course, including the uploading and scanning, things like that. But still, I think is fair. But let me think about it. If it's convenient enough, I probably gonna post a announcement. In the announcement, I provided a attachment. You can print it out as part of your answer sheet. Probably fine. That means I'm not going to be able to give any tricks in terms of connection, right? Sounds like you guys win, right? Have you think about that, okay? Here, it seems we really don't like to draw. I understand that, and if it is, without this pandemic, a lot of things going to become easier, but that's not realistic. And Ryan said, I also don't think that would work because lockdown won't let us print out the bus network anyways. I understand that, but Ryan, they're asking to give you guys ahead of time, in the ones of the before the exam. Okay, that's what they're asking for. This is what they're asking for. Yep. So they're trying to have some knowledge of the real problem before the exam happens, I guess. Any other questions? besides of this? Any questions? Any concerns? Anything? All right. So thank you everyone for attending today's lecture. And we still have Wednesday lecture for more Q&As regarding knowledge or the exam. So talk to you guys then. Thank you. Bye-bye.